Apparent horizon. From Wikipedia, the free online encyclopedia, at www.wikipedia.org. In general relativity, an apparent horizon is a surface that is the boundary between light rays that are directed outwards and moving outwards, and those directed outward but moving inward. Apparent horizons are not invariant properties of a spacetime, and in particular they are distinct from event horizons. Within an apparent horizon, light is not moving away from the black hole, whereas in an event horizon, light cannot escape from the black hole. It is possible for light to be currently moving away from the black hole, and so outside the apparent horizon, but in the future will not be able to escape. For example, because the mass of the black hole is growing, and therefore inside the event horizon. Thus, the apparent horizon can be thought of as the boundary of black hole for light at this instant, whereas the event horizon is the boundary of the black hole for light in the future. The notion of a horizon in general relativity is subtle and depends on fine distinctions. Definition. The notion of an apparent horizon begins with the notion of a trapped null surface. A compact, orientable, space-like surface always has two independent forward and time-pointing, light-like, normal directions. For example, a space-like sphere in Minkowski space has light-like vectors pointing inward and outward along the radial direction. The inward-pointing, light-like normal vectors converge, while the outward-pointing, light-like normal convectors diverge. It can, however, happen that both inward-pointing and outward-pointing light-like normal vectors converge. In such a case, the surface is called trapped. Consider the set of all such trapped surfaces. In the term of a simple Schwarzschild black hole, these surfaces fill up the black hole. The apparent horizon is then defined as the boundary of these surfaces. Essentially, it is the outermost surface of the black hole in this sense. Note, however, that a black hole is defined with respect to the event horizon, which is not always the same as the apparent horizon. Differences from the absolute event horizon. In the context of black holes, the term event horizon refers almost exclusively to the notion of the absolute horizon. Much confusion seems to arise concerning the differences between an apparent horizon, AH, and an event horizon, EH. In general, the two need not be the same. For example, in the case of a perturbed black hole, the EH and the AH generally do not coincide as long as either horizon fluctuates. In the simple picture of stellar collapse leading to formation of a black hole, an event horizon forms before an apparent horizon. As the black hole settles down, the two horizons approach each other and asymptotically become the same surface. If the AH exists, it is necessary inside of the EH. Apparent horizons depend on the slicing of a space-time. That is, the location and even existence of an apparent horizon depends on the way space-time is divided into space and time. For example, it is possible to slice the Schwarzschild geometry in such a way that there is no apparent horizon ever, despite the fact that there is certainly an event horizon. See also: absolute horizon, black hole, cosmological horizon, event horizon, particle horizon, trapped null surface, ergosphere, Cauchy horizon, Reisner-Nordstrom solution, photon sphere, killing horizon, and naked singularity. This audio was recorded on November 10th, 2018. To report an error or request a change, please send an email to wikiaudio999@gmail.com.